We have one final keynote for you here on this stage, where we are looking at the untapped potential of dark data. Taking us through that, let's welcome back Ian Wood, who's UK Head of Technology at Veritas. Hi again, Ian.
Hey, thank you, Marcus. And I just realized I am the last presentation, so standing potentially between cocktails or something else for afternoon entertainment. So I'll try and make this as light as and entertaining as possible.
I've been looking forward to this one, Ian. Yeah, all over to you.
Thank you very much. Good. So thank you. Welcome to my presentation, The Dark Side of Digitalization. As I look at the title, it looks quite scary, and it's certainly not the intent of my presentation. So in the presentation, what I'm going to really be covering and talking about is this concept of dark data and the idea that we've all lived in, that AI, machine learning, and actually everyday life relies on data. And we live in a mindset that the more data, the better. But actually, I'm going to have an opposing view that we have too much data. We have clutters of data that we need to categorize, sort out, remove, so that AI, machine learning, can be more effective, quicker, give the right answers in more effective time. AI, machine learning is absolutely top of mind in the news today, in any conversation, whether that's with a business leader or whether that's with my mother or my family at home. Some believe it's going to change our lives. Some believe it's the biggest threat to mankind. Either way, I'm going to suggest that AI is not new in any shape or form. In fact, Kate Crawford said a while back that AI is neither artificial nor intelligent. It's made of natural resources. It's driven by people performing tasks to allow for ultimately automation. And I like this concept of AI augments our everyday to make us a lot more effective. But AI requires data, and I think that's where my point of view is going to come in, that arguably we have too much data. We need to start reducing that data, categorizing that data. So looking at artificial intelligence, I'm going to go back in time into the mid-1990s and actually in the early 80s, where we used chess as a yardstick on how we are doing in the artificial intelligence world against humans and mankind. We looked at pairing up an artificial intelligent chess machine learning capability against some of the world's best chess players. In the early 80s, and arguably 50 years before this picture and this instance happened, the chess players and the chess masters were beating the computers fairly comfortably. But a monumental thing happened in 1997, where IBM set up a match between the world champion chess master, Garry Kasparov, and a supercomputer called Deep Blue. This, in fact, was a rematch, as the previous iterations, Garry won comfortably. But in 1997, Deep Blue won 3.5 to 2.5 in ultimately a breakthrough event in artificial intelligence, where the first illustration of a then called supercomputer could beat the world's best chess players. At the time, quite humorous, there was a lot of speculation that the Deep Blue had cheated. I don't think a supercomputer was going with any mind to cheat. Ultimately, later on, Garry did admit to the fact that the supercomputer was simply better and able to beat them, and no matter what. Interestingly enough, any computer that you were to go into any one of your favorite stores today and load up this computer program will be able to no doubt beat any chess master at a game of chess. And therefore, this yardstick of AI is an interesting one moving forward. So if you think a little bit about why did Deep Blue all of a sudden in 1997 win with this change, and was a marginal win and a marginal gain, but then was a landslide in the opportunity for AI to take over and ultimately become more intelligent? Well, firstly, it was the ability for Deep Blue to see more, the ability to see more potential moves. The game of chess is an interesting one and not a bad one to use, especially in the 1990s, as a yardstick for artificial intelligence. It's claimed the unsolvable puzzle. It has 10 to the power of 123 possible move variations, which is more than the atoms in the universe if you wanted to go. So therefore, not a bad idea. But why did Deep Blue beat Gary in this instance was the availability to process more potential moves, store more moves, and therefore see more than Gary or any human could in that game of chess. But chess is not the only game in which, not the only instance in which ultimately AI has moved on. AI is certainly a lot more than just Alexa or us playing around with open AI or ChatGPT in any shape or form. It's actually used in everyday life to ultimately improve our daily lives. In this instance, recently, a few weeks ago, AI was used to identify an antibiotic that could ultimately overcome an antibiotic-resistant bacteria, or otherwise known as a superbug. It used deep learning models to identify this new drug that can look at 7,000 drug compounds and combinations of each one of those drug compounds to ultimately overcome this antibiotic-resistant bacteria that we know today. And therefore, you can see that AI is starting to solve some key healthcare challenges in everyday life. I like this concept called augmentation. In this example, Chester AI, and Chester AI, for those that may not know, is an AI radiographer program initially created to teach radiographers to identify potential disease predictions. It's now used where people can go online today and you can go and upload x-rays, and it's starting to augment our lives to identify patterns and areas which could be threat to mankind by identifying those x-rays. And we see that all the time in healthcare, this augmentation concept and the ability for AI to go out there and solve bigger problems, perhaps complement nurses in Africa with knowledge that it can have, that your average doctor would perhaps have many, many years of experience to gather and gain. And therefore, nurses in Africa could just tap into AI to upload some symptoms that their patients are feeling. And AI has a better shot, again, it's controversial, but at least a really good shot at identifying what the issues could be with that said patient. And therefore, helping lesser developed countries to go out there and have a better healthcare system by augmenting what is ultimately a specialist doctor resource. And that's really what AI does. It augments our everyday. It has that opportunity to, using machine learning and artificial intelligence, run pre-programmed, repeatable tasks that, frankly, we want to go and leave to a computer to go and do, and we can get on with our everyday lives. So therefore, you may have heard this before. I've not done a digitalization presentation for the last 10 years where I've not used the phrase, data is the oil of the 21st century. It is ultimately the fuel that's fueling what we are right in the middle of the fourth industrial revolution that we live in today. Peter Sondergaard coined that from Gartner quite some time ago. And I think you're probably well aware that data is absolutely the fuel to AI, and data is the fuel to digitalization in everyday view. And therefore, we equated data to oil. And I guess looking at the current oil price, the price of data is pretty valuable. And therefore, maybe that's why everybody and all of us store data indefinitely for long times. However, here's the challenge. Data typically looks like this, whether it looks like this in one's desktop or email, whether it looks like this in any organization's network and file systems, whether it looks like this globally, it looks pretty cluttered. Why do we clutter all this data? Well, ultimately, I think of three things. Number one, as humans, we are data hoarders. We hang on to all of our data. We hang on to perhaps my tax return that I did in the early 2000s because we think it'll have some value in the future. We see organizations hanging on to the menu that they had in the canteen in 2001. Probably has no real value to that because they just think that the more we store, the more we can mine, the more value can have in that hierarchy of life. where we can store data that can be turned into information that can ultimately turn into knowledge, and in the higher order, wisdom. So we store that foundation of all that data. The other reason we store and data looks like this in most organizations or everyday life is the fact that it's just too hard to classify. Imagine those decisions. Every day you have to look at things. Do I keep this email or do I just delete it? It's so much easier to keep it, isn't it? Do I have to store this information on one area or another area? And again, that's pretty important to organizations because you need to know where your sensitive data is. But classification of data is really hard to do. And ultimately, that's the second reason in why networks like this look like this, and ultimately people don't do much about it. So in Veritas, we've done multiple surveys. And in fact, every now and again, most years, we do something we call the Databerg survey. And it's a report that we publish within Veritas, researching organizations throughout the world. And this is actually an extract of the UK Databerg. So what is a Databerg? Well, ultimately, a Databerg is a play on the concept of an iceberg, the concept that in anybody's organization or any everyday life, you have a bunch of what we are calling dark data. And in the UK organizations that we surveyed, 53% of their data was dark. What is dark data? Well, dark data simply means it has not been classified. We're not saying it's bad data. We're not saying it's good data. We're not saying it's valuable data. We're not saying it's invaluable data. We're frankly saying we don't know what it is. So lurking in dark data could be the most sensitive, critical data to any organization. But due to the fact that they haven't got effective classification, effective means to monitor and understand their data, it's still categorized as, or uncategorized as, dark data. Above the surface is what we have visibility to that data, which is really 47%, the remaining. What's interesting about the remaining data, only 19% of that data is mission critical, sensitive, and critical data in essence. And 28% is rot data. So what is rot data? Redundant, obsolete, and trivial. Redundant means that ultimately it's been copied multiple times and exists elsewhere. Obsolete means it's really old. It's probably something I don't need and I should have deleted no matter what. And trivial is, frankly, it's easier to recreate than to store and manage from our everyday lives. And again, my call to action here is we need to start identifying, classifying data. We need to start tagging it. We need to start managing data to make that artificial intelligence engine more effective, and also to save a lot of money if you're an organization, or in today's world, what I look at is to save a lot of CO2 emissions that are hitting the world today. In the UK, we predicted that 6.4 million tons of CO2 is attributed to dark data. That, by the way, represents around about 1.5% of the total UK emissions. Simply having all this data stored and run from a day-to-day life is wasting very, very valuable energy resource that is, again, not only important to the climate today, but also quite costly for anybody as well. So it's really a call to action to start clearing up data. It has a cost implication. It has a social implication to making sure that we're more effective and responsible in storing data. However, it also has real problems to anybody out there, especially organizations. On the left-hand side, data privacy has become top of mind, and something I talked about in the panel this morning. The regulators are starting to gain teeth. They're starting to have fines, and many organizations are experiencing fines if they've mistreated data and they don't adhere to the GDPR or data privacy regulations around the world. This is just a snapshot. It's not meant to be me naming and shaming organizations. It's publicly available information, but there are organizations that have been fined an awful amount of money with mistreating data. So you can imagine if that organization has a lot of dark data, what you can't see, you can't manage. So there's a real implication to the risk of data, treating it responsibly. So Amazon, basically 746 million euros of multiple fines of data privacy breaches. And for instance, that's quite interesting about that. I had a look at this, and the real top of mind stab, that's around 75 million Prime subscribers. That is the cost implication to them, to their business. H&M, 35 million euros. I didn't do that equation of how much that's going to cost H&M in terms of clothing, but I think it has a real impact perhaps to my daughter, which certainly has a lot of shoes that she could buy with 35 million euros. I'm sure she'll be excited about that. On the other hand, dark data, if you're not managing that data effectively, has a real threat to it, right? Imagine sensitive, critical information that you don't frankly know where it's stored, how it's encrypted, how it's protected. So this concept of having a potential ransomware attack every 11 seconds means it's not a matter of time, it's not a matter of if, it's a matter of when. You could be breached, have your data compromised, have it encrypted and damaged. So knowing where your data is quite critical to protecting it and making sure it's secure, whether you're an organization or whether you're using data everyday life. So my call to action is about time we started to look at data, start managing that effectively, because ultimately it's going to have a real big impact. So what I'm going to do now is change gear totally, because actually what I believe is that we can use artificial intelligence, machine learning to manage our data. So on the one hand, I talked about this concept that, hey, perhaps the world has too much data. With too much data, are we going to get the right answers with artificial intelligence and solving the right problems? Surely if we have effective data, we remove the rot, we have a view of where our data is, we classify our data, AI and machine learning can be a lot more effective. So I'm going to go through 3 ways in which I've seen AI can help manage our data. So using AI to make itself more effective. So the first one is in data discovery. Actually, this is a bit of a plug to Veritas. This is a screen grab from one of our dashboards that drives our data analytics engine within Veritas. So what we can do now is, instead of just using AI to win a chess or solve healthcare problems or predict when my family may need new toothpaste, we can point AI and machine learning at solving data problems. So we can use this to manage dark data. Ultimately, data discovery is one of the first areas in which we can use machine learning, artificial intelligence to help discover data assets, and then to put it through an engine to help classify. If you remember earlier on in my conversation, why is data cluttered? It's frankly very difficult to make data decisions, whether this is sensitive data, whether the PII resides within those files that you stored, or where PII resides, or personal identifiable information. So in this instance, we're using AI within Veritas, machine learning to discover data sources, and we're using that to put it through a classification engine to predict what data resides in your organization, and ultimately classify where it resides, who has ownership, what the type of data files are, perhaps even identify where malware can reside inside files and data, and ultimately shine a light on dark data so that you can make data decisions. And we've implemented this in many organizations, small and very large, and ultimately really helps them manage their data inside their enterprises a lot more effectively. You can also imagine, although this screen grab may be quite small for you, if you go into the detail in this screen grab, we're able to identify where PII data or personal identifiable data is. We're able to classify what data is per type of department, and therefore it's used where IT specialists like myself can go into lines of business where you may be working and have fantastic conversations about data to ultimately clean up that data. And what I've seen as best practices is data cleaning days. Can you imagine that? Hopefully this is, I'm a data person. It's really interesting and exciting to me. So ultimately we have a day where that organization's working with data, which is this kind of dashboard, have a data cleansing day. Let's go out and clean, classify, more importantly, learn how to use that delete key to rubbish data, rot data that may be cluttering up your network. The second area where I can see AI helping and using dark data to affect. So in this instance, we're showing you the use of natural language processing. So again, another screen grab with some circles. I hope you're not going into too much detail of what we're saying yet, so just bear with me on the concept. But using NLP or natural language processing, what we're able to do is do one of two things. One, identify fraudulent or risky discussions or discussions you ultimately don't want to be happening in collaboration systems that are stored in unstructured data. So example could be if you are in a regulated environment, perhaps you're in finance and it's highly regulated, and you are doing trade conversations using a collaboration platform like WhatsApp Enterprise or Bloomberg or Teams or any of those collaboration services, we're able to use NLP, machine learning, to go out there and identify when perhaps fraudulent or frankly inappropriate conversations are happening, so that you can provide something called supervision. So you can go in and say, hang on, I'm redacting all the information because I may not want to see it. However, the system has alerted me to conversations that shouldn't be happening. The other one is sentiment analysis, you may have heard of. So that could be storing large amounts of surveys or chats that your organization could have. All of that data is potentially stored in unstructured data sources, again, building up dark data. But the idea of using NLP, looking at those data sources and understanding sentiment by using a mathematical formula based on NLP to give you a sentiment score of really bad, this particular customer or this particular area just does not like us and we better act upon it, or this particular area thinks this product or this area is fantastic and giving us a very high sentiment score. So I've talked about discovery of data using AI. I've now talked about this concept of using natural language processing with the ability to use AI to go in there, mine dark data, and get value from that dark data source. The final area I'm going to quickly talk about is the concept of using data access and data interaction for some form of anomaly detection or predictive analysis. So the idea being that if we can store data about data, right? So again, we may be storing more data, but this is valuable data, not dark data. We're able to analyze interactions with data. On the right-hand side, you'll see something called a social map. Again, please, an eye chart. I'm not expecting you to understand the detail of this chart. It's just a concept. But the ability to say, look, these are all the individuals around that are interacting with a piece of data. And then all of a sudden, through some form of anomaly detection on everyday basis, Mary or John is interacting with this data source. All of a sudden, someone else is interacting with that data source and doing things they shouldn't do. So using that anomaly, right, picking up where things aren't normally going according to plan and highlighting that, and there's access of data to do values. Could be data theft. It could be a ransomware event that's encrypting all your data. So yesterday, this particular user would access a file once and never again. All of a sudden, this particular user is reading vast amount of data and then writing vast amount of data. Well, that sounds to me like a compromised laptop or computer system that could have malware that is currently activated and doing an encryption event. The other area we use anomaly detection is in data protection solutions. So being able to say, like, on every given day, your backup workload is a certain type. All of a sudden, that particular system's backup workload is increased significantly. All of a sudden, you could be creating way more dark data than you want to, so act upon it. Or again, tell me that there could be an encryption event from a ransomware attack on that system. So this idea, this third and final area of using AI to manage our data more effectively, is to look at the access of that same data, because if you go through the pattern of what I discussed, number one, you've classified that data, right? So you understand that data through discovery. You could be using NLP to get more value out of your dark data. And then this is the third area. We're able to look at the data and how it's accessed. We know what it is. We've classified it to pick up any anomalies that could be happening. So what I presented there is hopefully a good overview of how you can use AI, machine learning to make dark data go away. Because once we've shined a light on data, you know what that data is. By definition, it's no longer dark, and you can act upon it. You can store it more effectively. You can learn to use that delete button, or you can go and move that data to somewhere else that you may not want in an archive layer or something else to that effect. My final slide, and we can open up to any Q&A, is just a bit of a Veritas plug of who we are and what we do. So if you're not familiar with Veritas, we are a data management company born really out of managing data more effectively. We've been in the industry for 30 years, solving fairly complex data management problems around protecting data, around making sure applications are resilient, and then finally, making sure organizations remain compliant and govern their data more effectively using software technology. And the feature set I've just done is around how we're using that software technology to solve this concept of dark data. Because my belief is the cleaner the data we can have, the more fruitful AI and machine learning capabilities are, because ultimately they do rely on data. And that's really it from me. I don't know if I've run long or early. I didn't have a timer, I'm sorry, but that's finally for me. We could hand over to any questions that we may have.
Thank you, Ian. Yeah, we're a little bit tight on time, but we've got time for a question or two at the end. What for you are some of the challenges or main challenges associated with working with dark data, would you say?
Yeah, number one is identifying that data, right? I think if I go back to the discovery, that's the number one. You know, if you inverse the question, Marcus, where do we start? It's discovery, and actually that's the biggest challenge. Everybody I interact with, very few know where their data really resides. And I think if they normally say, look, I know exactly where all my data is, they either have very effective tools, or perhaps they're too embarrassed to say, well, frankly, I don't really know where the data is. But by and large, the majority struggle to discover dark data. So that, and again, that would be my advice, is invest in technology. And many a computer specialist, a CIO, whatever, they would say, look, yeah, and I've burnt my career on trying to classify data and failed. But that was many years ago, before technology. AI, machine learning came along to help you classify that data so that you can shine a light on it. So that would be my biggest kind of area, Marcus.
I've got another quick question here. I wonder if you have any real-world examples of any organizations that have successfully leveraged dark data, and perhaps we could build on that with how those best practices can be used in other use cases, maybe.
Yeah, it's a good question. I think the I don't want to disclose the organization's name because I don't have permission, but I've certainly seen, so I mentioned finance right now. Finance organizations, and the example I'll give is a large UK bank. Finance organizations really struggle. Well, they don't struggle. They are really heavily regulated. And part of that regulation is they need to monitor and provide supervision. And so this particular organization is storing vast amount of collaboration. That collaboration isn't just Teams, WhatsApp Enterprise, Bloomberg, all the collaboration platforms we use at the keyboard. It's actually voice and telephony as well. So what they've able to do is firstly learn to store and capture that data, which is the first thing they do, is capture that data in an effective area. And we help them capture the data into a vault, so it's super secure, no matter what it is, whether that's voice, whether that's collaboration, and then they can use machine learning to classify, like I mentioned, and then they're able to use sophisticated discovery. I'm getting plugging too much of Veritas, but we're able to discover, so they can go in and discover, as I mentioned earlier, wherever there's a fraudulent conversation. And the regulator, what they want to see is, I want proof that you're supervising. It's no good to go and say, once the horse is bolted and we've had fraudulent trade, we will do better next time. They want this monitored and supervised. And so they use this to supervise all of their trades.
Fantastic. Ian, thank you for joining us today. It's been a real pleasure. Really enjoyed your company. Thank you very much.
Thank you, Marcus. Thank you, everybody, for listening in.